So, when it comes to infrastructure as code, version control is key. It's like having a blueprint for your entire setup, right? You want to be able to track changes and roll back if something goes wrong.
Yeah, definitely. Git seems to be the go-to tool for that.
Absolutely, Git is the standard, but you have to use it properly. For instance, branching strategies can really help manage different environments or feature sets. And don't forget about pull requests. They're not just for code reviews, but also great for ensuring your infrastructure changes are thoroughly checked.
That makes sense. I've seen some projects where everything was in the master branch, and it got pretty chaotic.
Exactly. You need clear separation between development, staging, and production branches. And tagging releases is super important too. It helps keep track of what's actually deployed versus what's being tested.
Tags can get messy though, especially with lots of small updates.
True, but using semantic versioning can make things much clearer. Major dot minor dot patch kind of thing. Also, automated testing on pull requests is essential. Imagine merging a change that breaks your CI/CD pipeline because someone forgot to update a configuration file.
Automated tests would catch that early on then.
Precisely. Plus, integrating with tools like Terraform or Ansible can streamline this whole process. Terraform state files should always be versioned too. Otherwise, you risk losing track of your actual infrastructure state. Speaking of automated testing, that's another crucial aspect of infrastructure as code. You want to ensure that your configurations are correct and won't cause issues when deployed.
Definitely. What are some good strategies for setting up those tests?
Well, start by writing unit tests for individual components. For example, if you're using Terraform modules, test each module independently to make sure it behaves as expected under different conditions.
Testing individual components sounds like a solid approach.
Absolutely. Then move on to integration tests to see how these components interact with each other. This is where tools like Teratist or Inspec can come in handy. They allow you to simulate deployments and verify the state after applying changes.
Simulating deployments must help catch a lot of potential issues early on.
Exactly. And don't forget about smoke tests, quick checks to ensure basic functionality works post-deployment. These can save a lot of headache by catching obvious errors before they impact users.
Smoked tests seem really useful for initial sanity checks.
They are. Also, consider running periodic compliance checks using tools like AWS Config or Azure Policy. This ensures that your infrastructure adheres to security and regulatory standards over time.
Compliance checks would be great for maintaining long-term stability and security.
Indeed. Continuous monitoring through logging and alerting systems can also provide real-time feedback on any deviations from desired states. All these pieces together form a robust testing strategy that minimizes downtime and maximizes reliability. Speaking of which, choosing the right IAC tools and technologies is just as important. It can significantly affect how efficient and effective your workflow is.
Absolutely. There are so many options out there. Terraform, Ansible, Chef, Puppet. How do you decide which one to use?
Well, it depends on your specific needs and existing tech stack. Terraform is great for managing multi-cloud environments because it supports a wide range of cloud providers. Plus, its declarative syntax makes it easy to understand and maintain.
That does sound versatile.
On the other hand, Ansible is fantastic for provisioning servers and automating configurations due to its agentless architecture. If you're already familiar with YAML and have a lot of server setups to handle, Ansible might be the way to go.
The choice seems to depend a lot on what we're already working with.
Exactly. Another factor is community support and documentation. Terraform has a large community and extensive documentation, which can be invaluable when troubleshooting or learning new features.
Community support definitely plays a big role in adoption.
Definitely. And let's not forget about integration capabilities. If you need tight integration with other tools in your CI/CD pipeline, something like Jenkins X paired with Helm charts could be very powerful for Kubernetes-based deployments.
Integrations can really streamline the whole process.
They can. Ultimately, the goal is to find a tool that fits seamlessly into your workflow while providing robust management capabilities for your infrastructure. Another critical aspect is modular design and IAC implementation. Breaking down your infrastructure into smaller, reusable components can greatly enhance manageability and scalability.
That makes sense. How do you typically structure these modules?
Ideally, each module should encapsulate a specific piece of functionality and be as self-contained as possible. For example, if you're using Terraform, you might create separate modules for networking, storage, and compute resources. This way, changes to one area don't inadvertently affect others.
Keeping them isolated sounds like it would reduce risks during updates.
Exactly. Each module should have clear inputs and outputs defined, making it easier to understand dependencies and how they interact with the rest of the system. It's also helpful to document the purpose and usage of each module clearly.
Clear documentation is crucial for maintaining consistency across teams.
Absolutely. And versioning your modules is important too. If you update a module, bump its version number so that anyone using an older version knows there's been a change. This helps prevent unexpected behavior when deploying new versions.
Versioning would definitely help keep track of changes and upgrades.
Definitely. Lastly, consider reusability. Design your modules so that they can be easily reused across different projects or environments. This not only saves time, but also promotes consistency and best practices throughout your organization. Speaking of which, parameterization techniques are essential for managing environment differences in IAC. It allows you to use the same codebase across multiple environments like DED, staging, and production without duplicating efforts.
That sounds really useful. How do you typically implement parameterization?
One common approach is to use variables and input parameters. For example, in Terraform, you can define variables at the top level of your configuration files and pass values to them via TVOOR environment variables.
Using different TT files for each environment seems practical.
Exactly. This way, you can have a single set of infrastructure definitions and customize the behavior based on the environment-specific variables. Another technique is to use conditional statements within your IAC scripts to handle different configurations dynamically.
Conditional statements could be handy for varying settings.
Absolutely. For instance, you might have a condition that checks the value of an environment variable and applies different settings accordingly. This keeps your code dry, don't repeat yourself, and ensures consistency across environments.
Keeping things dry definitely helps with maintenance.
Definitely. And don't forget about using data sources and external lookup mechanisms. For example, fetching secrets from a vault service or pulling configuration details from a centralized database can help keep sensitive information out of your version-controlled repositories.
External lookups would add an extra layer of security and flexibility.
Exactly. By combining these techniques, you can effectively manage differences between environments while keeping your IAC definitions clean and maintainable.